All right, this is the last part to the assignment. We're starting at 24. An object moves along a vertical path, and its position is given by y at t equals t times e to the t plus 1, where y is measured in centimeters and t is in seconds. Part A. What's the object's position at -2? So plug in -2, answer it. I'm going to get my answer key up again. It just went black on me. Always double checking to make sure I'm doing it right with you, or if I made a mistake, I know why I made a mistake. So this is, and you can write it however you want to write it. All that, it means the same. Part B, and that's in centimeters. So we have our units. That's a number. Find the equation of the velocity. Let's do that together. That's going to be the product rule, t times. So that's the first times the derivative of the second. So e, you copy. The hook on would be +1, which we don't need, plus the second times the derivative of the first, which is 1, which we don't need. So there's the velocity equation. Part C says find the velocity at -2. So let's do that. So all we have to do, into the velocity, plug this in. This actually might also be helpful if we factored out e to the t plus 1 and be left with t plus 1. That might be just easier to evaluate. Both will give you the same answer. So if I plug in -2, -2 plus 1 is e to the -1. This is also e to the -1. That's a great answer. If I use this one up here, I mean, you can combine like terms here too. So that's -e to the -1 or -1 over e. That means all the same thing. And that's centimeters per second, I think. Yes. D. Acceleration equation. Let's take the derivative one more time. So I'm actually going to take this derivative up here and do the product rule. So the first times the derivative of the second, that's just 1, plus the second times the derivative of the first, and the hook on is 1, so that's it. And again, to make life easier, I'm actually going to factor this. So e to the t plus 1, factor it out, and you're left with 1 plus t plus 1. You could also write that as t plus 2. And there's the acceleration. E says find the acceleration at -2. Which is easy because -2 plus 2 is 0, and 0 times anything, the answer is 0. And the units would be centimeters per second squared because it's acceleration. Part F. For what intervals of time is the object moving downward? That would be a negative velocity. So if you take the velocity equation, and I said the velocity, use the factored version. So there's the velocity equation. Make it equal to 0. E to whatever exponent will never be 0. So the only answer for this, where the object is at rest, is at -1. So from -1, in terms of the velocity, what would happen if I plugged in a number smaller than -1? You get a negative answer. Bigger than -1, positive answer. The question is, when is it in a downward direction? And that's -infinity to -1 seconds, because that's where the velocity is negative. G. Find the object's minimum position and justify your answer. So in terms of this tells you that it goes from negative infinity to negative 1. So at negative 1, we have a minimum value. So even though it's going in a downward direction, so if it's going in a downward direction, it has to start from above. And then at negative 1, it increases. So at negative 1, it's a minimum, right, for position. So if you would justify that the velocity is less than 0 before, and then the velocity is greater than 0 after, and that you could see it's a minimum at negative 1. G, is there a G? Yep. So 24G, find the object's minimum position. I just did that. H. Where did that piece of paper go? That I just like threw to the ground. I don't know what happened. All right, so we just did that one. I'll use a calculator to find the total distance traveled. So for total distance, we're going to integrate the velocity, and it's the absolute value of it. So we're going to go negative 2 to 2, and we're going to integrate the velocity equation. So where did my paper just go that I just like threw to the ground for number 23 and 24? All right, I think I found it. So to find total distance, it's the absolute value of velocity from negative 2 to 2. So in our case, into the calculator, our velocity function is e to the t plus 1 times t plus 1. That's what it looks like. What does it look like on a calculator? Menu, calculus, integrate, and again we're going to go from negative 2 to positive 2, absolute value, and then type in e to the t plus 1, move the cursor, parentheses, t plus 1, and then that's a dt, not dx. And I get 41.435, which is the right answer. All right, that was it for 24. 25. Use a calculator. Hey, I have it in my hand. To evaluate problems 25 through 27. So find the derivative at 1 for that function. Can you use your calculator? Good, a little practice. So I want to find the derivative at 1 for that. How do I do that on our calculator? We're going to press menu. We're going to go calculus and derivative. And it's derivative at a point. So 2. The variable is x. The value is at positive 1. Press enter and then enter in the square root of e to the x. Move the cursor plus 5. Move the cursor. That's it. I guess we got it now. And you get the answer. 0.4. Make sure I'm doing it right. 25. Oh, ha! It's 1.237. What was I doing? I can go back and correct it. I just don't know what I was doing. 1.237. I was looking off the answer key and said, that's not right. All right, let's go here and just change that to 1.237. There it is. Does that look right? Yeah, 0.592. All right. 26. The second derivative, 1.237 of the same function. Go menu. Oops. Again, calculus, derivative at a point. The variable's x, again, the value now is 1.237. And now we're actually doing the second derivative. So click over, make sure it says second derivative and enter. And then type in the square root of x e to the x plus 5. Control enter, and it's 0.471. You can truncate, it's okay. 27. We're integrating from 0 to 1.237, the square root of e to the x plus 5. Menu, calculus, integrate. And we're going from 0 to 1.237. And then type in the square root of e to the x plus 5 dx. So type it in. So you get 3.263. Good practice, right? Do you have some basic calculator skills? 28, use the trapezoidal rule with n equals 4. And we are approximating 0 to 2, 1 over 1 plus x cubed dx. So using the trapezoidal rule, the width, the top subtract the bottom divided by 4, so the equal width will be 1/2. The formula is also 1/2, so it's 1/2 times the width, which is 1/2. The first height, we plug in 0. Don't be tricky. Then we double, and we plug in 1/2, because we're going by halves. And then we double again. The next half would be plugging in 1. We double again. The next one would be plugging in 3 over 2. And then the last one, you would not double. Oops, there it is. So plug in 0, 1/2, 1, 3 over 2. We're just counting by halves until we get to the upper limit, which is 2, which is what we have right now. Oops, don't double it. And there it is. That's called the trapezoidal rule. Number 29. We're almost there. These are all limit questions. So let's do that. Limit is ultimately a substitution question. And if you can't substitute in to get the answer, then you have to do some fun algebra. So if I look at 29, just substitute -3 in. I can see that it's not going to be undefined. So whatever that answer is the answer. So that would be -7 over -5. Or 7 over 5. $30. Again, we start with a substitution. If we know it's undefined, don't put it down. So here we have the limit as t approaches +2. So mentally, I can tell that if I plug 2 into the denominator, the answer is 0. So even before I do that, let me factor. Anytime you can factor something, just do it. It's going to lead to something good. So let's factor this. So +2 and -2, -1 and -2 know how to factor. If I plug positive 2 in, it gives me a 0 in the denominator, but I can see that it's removable. And now plug 2 in, and you get 4 over 1, or just 4. Number 31, again, a limit question. What we don't practice, we're going to forget, right? So the limit as x approaches negative 1, x plus 1 over the square root of x squared plus 1. So step 1 here is what happens if I plug in negative 1. It's undefined. So I need to do some algebra in order for that to not happen. So I'm going to multiply top and bottom by the square root. Oh, garbage. Plug negative 1 in, and I didn't simplify it right. Negative 1 squared is positive 1. So what you end up with is negative 1 plus 1. But in the denominator, you actually end up with the square root of 2. That's beautiful. Negative 1 plus 1 is 0 divided by root 2. That limit is 0. There's no 0 in the denominator. I was just being silly. Number 32. Last one. Whenever you get a limit question going to infinity or negative infinity, it's power terms that they're looking for. It's the end behavior. So if I look in terms of understanding the same function and what the end behavior is, what I'm looking for is right here, right? It's x over the square root of x squared. Now, that does simplify to 1, but here's the thing. If I put in a positive number, you get the answer positive 1. But if you put in a negative number, what happens to the same thing is that a negative number over itself would actually end up being a negative divided by a positive, but the same number. So the left end behavior here is negative 1, because as it goes to negative infinity, it'll be a negative divided by a positive. So it does simplify to 1, but it could simplify to positive 1 or negative 1. It's like solving a quadratic. It could be positive or negative x. So this is true. On one side it's positive 1, and on the other side it's negative 1. So the left end behavior, it's approaching negative 1. Done. Mr. G Math over and out. You did your homework, right? That's right. Till next time. I'm proud of you. You completed your work. That's awesome.